Thank you, Dave, and thanks to Chip and the Radio Club of America. And I think Chip said I got an hour, is that right?
An hour equals an hour in your case.
Yeah, my kind of talk, yeah. Okay, Charles. Yeah, 5 minutes, okay. Anyway, I want to give a tutorial. I was going to be here earlier, but we got caught in the traffic jam out there. So Alan graciously took over, and you sure you don't want to come up and give this talk too? You're on a roll.
I don't have that much beer.
Okay. Anyway, let's go on here. So before we start talking about AI and how great it is and everything, I thought a comparison should be made to something we all have inside our heads, okay, the human brain. And it's pretty interesting when you consider the speed of memory in the brain and power and all that. So if you look here, over to the left there, that's the world's fastest supercomputer called El Capitan, and it's at Lawrence Livermore National Lab where I used to work. And it has about 1 exaflops. That's a 1 with 18 zeros after it, okay? And the human brain also has about 1 exaflops. It's pretty amazing. Now, the power requirement is really interesting. That computer takes about 20 to 30 megawatts of power. The human brain's about 10 to 20 watts, okay? So quite a better efficiency. The dimensions, as you know, the brain's like 3 pounds or so, that computer and the building and everything. The cost, $600 million plus. The brain, well, there's no cost on that. I mean, so that's way out there. The cabling is interesting. The El Capitan has 90 miles of cabling, but the human brain has 528,000 miles when you consider all the neurons and axons and dendrites. The memory, the computer, we can put more memory in, okay, 700 petabytes. Petabyte is 1 with 15 zeros after it. But the human brain has about 2.5 petabytes. And the storage, the computer has about 58 billion transistors. The human brain has 125 trillion synapses, and each one can store 4.7 bits. So the brain is still pretty much a great thing, okay? We'll talk where the brain is still better than AI. Okay, so this is supposed to be a tutorial. So what is AI, okay? AI is where you try to simulate what humans do, but you do it on a computer. Many great things are there waiting for us with AI, such as speech recognition, translation of languages, things like that. The human can still do better, though, okay, in translating and getting things out with our petaflop memories and so forth. So anyway, trying to simulate human things is what AI is on a computer. There's different types of AI, reactive machine, like the Deep Blue chess game, okay? So you react to anything that's happening in the present. Limited memory, like a self-driving car, okay? So you use past data of how cars drove and everything, and you put that in. And then these are things that can actually exist right now, as we know. But then in the future, things like human emotions or intentions, like that arm wrestling, how's the guy going to push harder and things like that. And then to get way out there is like consciousness and getting aware that things are happening around you and things like that. So AI has a couple of other things involved in it, as Alan talked about, machine learning, and there's something called deep learning. Machine learning is a subset of AI, and deep learning is a subset of machine learning. And so machine learning is where you allow the computers to learn from all the data that you try to put in, like that, what he was trying to do with the propagation, okay? Not too much programming, just like, it learns from data, that kind of stuff. Deep learning is where you're really trying to simulate what's going on in the brain with what's called neural networks and things like that. And so there's machine learning and deep learning. So machine learning, there's different types of machine learning. There's what's called supervised learning. That's where things are labeled, okay? So like all those fruits have some kind of markers or labels on, and then the computer takes that and it does some kind of image processing to pick up what the labels are, and then it sorts it out so it puts it in the right boxes, okay, to be shipped to wherever. Unsupervised learning, that's called clustering, and that's where the computer, it has to do a little bit more than the labeling. It has to somehow look at the objects and see if there's a pattern with those objects, and then it goes and sorts them and basically does the same thing as what the label, but it's a little bit harder to do. Okay, but those are the types of things, and you can always have reinforcement training. Deep learning, this is where you're trying to simulate what's going on in the brain, which is called artificial neural networks, deep neural networks, and the complex patterns and things that flow with the data. And so neural networks have neurons and layers and connections and weights, and it's a whole science into itself, trying to simulate what's going on in the brain. Some of the things that this is great for is image recognition, okay, which, there's some of that exists already. When you log into the computer, your face is on there and you get logged in. If Angel's face is there, it doesn't get logged in, But anyway, translation and language things, the human still can do a lot better and faster in translating than what the best computers can do now. But in the future, you'll have something on you and you'll speak in one language and it will be speaking to somebody else in a different language in real time, okay? We're not quite there yet. So some of the applications of AI in the healthcare, it was like diagnosis. That's going to be a big thing because, how can one doctor or even a group of specialists know everything about every disease and every treatment? And so AI can go through all that data and you'll have the best doctor in the world then, and new kind of drugs, coming up and things like that. Finance, fraud detection, and trading of stock, things like that. Hopefully we'll get better. Self-driving cars we talked about, and how to manipulate traffic if you get self-driving cars. Entertainment, gaming, that's a big thing. There's a lot of gamers out there that it's going to be great with AI. Education, I was in the education business as a professor, and I used to have this method. It was pretty good. It might even beat the AI. I would put this dartboard on the wall, okay, and in the center, throw the dart, that's an A, and then the next ring was a B, and so it made grading very easy, but hopefully this will be better, okay? And of course, robotics we know about. And it looks like I'm cut off a little bit at the bottom there, but amateur radio, all kind of things in amateur radio. So I'm going to talk a little bit about that next. Yeah, boy, this computer's really messed up. Anyway, It should say, what's the optimized wideband antenna? I did an antenna design some years ago that used something like AI, but it wasn't quite AI yet, okay? And I just thought I'd explain a little bit about that and some things that are related to AI, and then how AI will do antenna design in the future. Anyway, this OWA Yagi came from actually an OWA antenna that was on a cell phone, okay, Qualcomm and Sony. And then I said, can we apply it to Yagis? And it was putting extra wires of some length and spacing very close to the main radiator. And so what's optimization? Optimization is where, with this simple case here, 2-element Yagi, you would change the spacing between the Yagi, and you would change the length of, say, the reflector, okay, or director. And you might get something that you're adjusting for front to back ratio, and it has some curve that looks something like that. And so that red peak there would be the best front to back, but you're looking for the minimum radiation in the back, so you're looking for those minimums. But there's one that's bigger than the other. That's called a global. Okay, so you come up with methods to do global. So here's a really fancy function. It has a lot of peaks in it. And one of the things that's a lot of these new optimizations techniques that were sort of related to AI is where you try to use nature involved in doing the optimization. So this one's called ant colony optimization, and it's basically you put a bunch of ants there and you program them up, and then the ants leave trails, chemical trails going to the food, and so they don't go back on those same trails, and you can let the ants go. And this is a simulation that just shows how the ants are going to move, and you'll see them moving around, and they're going all over the place, and they keep trying to find the food, okay? And finally, they got it, okay? There's another one that's called firefly optimization, and that's where you have fireflies, and they have indicators with the lights. They light up or don't light up, and that's how some fireflies know not to go to the same position. And so here's all the fireflies get started, and then they keep going. And there they go. And there's that one guy that's sort of, I don't know why he's out there. There's one guy off to the right that he finally gets there. And then you could come up with algorithms. You could find all the peaks. Suppose you have a whole bunch of peaks, and so you let this one go. And so it's finding all the peaks, and all those other circles are the dips in that function, okay? And so that's pretty neat. And there's all kind of things that involve nature and things like that. So anyway, I applied this to a Yagi, and we tried to get the best bandwidth, the best VSWR, front-to-back ratio, so forth. And when you run this through an optimization, like one of these things I just showed, you can get a almost perfect SWR over the 20-meter band. And then you can also get the front-to-back ratio, which is the blue scale on the right there, more than 24 dB across the band, and the gain's about 9 dB across the whole band. So AI, where's AI going to come in antennas? It turns out there are some commercial codes right now that actually have this machine learning in them. One of them is called FICO, and it's from a company called Altair HyperStudy. And what it does is it takes something like this Yagi antenna, and it trains it with a very specialized algorithm called FAST, that if you're familiar with this mathematically, it uses something called fancy regression analysis to do fits of all the different parameters that you're varying, and then it stores a big database of gains and front-to-backs and SWRs for every possible situation. And so you do that once, and you store all that data, and that's the learning process, the machine learning. And then when you do the optimization, it just has to go on that database, and it has all the data there, and it's like super fast. Those ants or fireflies can get to the optimization like that, where the kind of optimization that is the classical, it takes like, maybe hours to optimize something. And so this is going to revolutionize all kind of things with circuit filter design, things like that. But this is an example right now that you can use for antennas. And I can't go in to show you a sample and all that. It would take too much time, but it's out there, okay? And so you're going to see this eventually. All the stuff that's commercially eventually gets into ham radio, okay? And that's what we want. So just a little bit of PR here on the OWA Yagi. It's used all over the world and everything, and I didn't have machine learning. I had to use the classical techniques of optimization, but it came up with some pretty amazing antennas. And I just put in Google OWA Yagi, and I said, put out all the images that it finds on this. And this is just the first page, okay? It's page after page of people using this antenna. Now, here's the coup d'etat, and this is especially for Chip back there. Okay, the next slide. Turns out I don't really know much about AI, to be honest. I was a professor at Penn State for 33 years in antennas, but of course I've heard of it and so forth. But what I did is what the students are doing these days, okay? And you know, I'm saying it, so don't crucify me, but if a student does this, not good, okay? And they use something called ChatGPT and other things. But this is Gemini. Some of you may know about Gemini on Google. And all I did in Gemini is I made a screenshot of exactly what I did before this presentation was made. And I said, make a PowerPoint presentation for a tutorial on artificial intelligence. And it came out with every slide here, what pictures to put, all the bullets and everything. So Gemini really gave this talk, I should say. So, thank you.